Hello students, in this class we will discuss types of armature winding, which is a portion of first chapter, that is alternator. The type of armature winding are briefly classified into four types: full pitch winding, short pitch winding, concentrated winding and distributed winding. First you see what is full pitch winding. If the distance between, the definition of full pitch winding is if the distance between two coil sides of a coil is one pole pitch, that is 180 degree electrical or 360 degree by P mechanical, where P is the number of pole present in synchronous machine. In terminology, we already discussed what is coil side, what is pole pitch. So, I think that you are very clear on that terminology part, which are helpful for your better understanding of different type of armature winding and also for finding winding factors. Okay. So, what is full pitch winding? It means you know that the side of a coil, this is a coil. I take the example of a synchronous machine having 2 number of pole in the rotor and 8 number of armature conductor. Okay. And let I place a coil in between the slot 1 and 10, in between the slot 1 and 10, 1 and 10, and just I open this and draw its slot diagram and show the coil in between the slot 1 and 10. Here you see that these two coil side means if I place the conductor or coil in between terminal 1 and 10 by taking one slot as its incoming and another slot as its outgoing. So, 1 and 10 are its coil side. Suppose it is a winding. Okay. So, this one is one end and this one is another end. So, this is the starting point, this is the ending point. If the distance between these two coil side is equal to one pole pitch means if the distance between two conductor is 180 degree electrical or it is 360 by P mechanical. So, here it is clearly visible that the distance between these two conductor is 180 degree, then only the winding is named as full pitch winding. If you see this diagram, in full pitch winding, if one of the conductor side, if one of the coil side is under north pole, then another side is corresponding south pole. If one of the conductor, that one side, coil side 1 is at slot 1, if its coil side 1 is present under north pole, then another side is under corresponding south pole. Then what is the total EMF of this coil? And here, as the coil span between these two conductor is 180 degree, the total EMF induced in this whole coil is the algebraic sum of EMF induced in coil side 1 plus EMF induced in coil side 2. Suppose this is the coil side 1, okay, this is the coil side 1, this is the coil side 2. Let here EMF induced is E1, here EMF induced is E2. And these two EMFs, as here coil span is 180 degree, these two EMF E1 and E2 are 180 degree in phase with each other. So, if you draw the phasor diagram, then E1 added with E2. So the resultant EMF is E. Clear? Now come to the short pitch coil. What is short pitch coil? If the coil span between the two conductor is less than 1 pole pitch, means less than 180 degree electrical, then it is called as short pitch coil. The same example I will take for explain this short pitch coil. The same example, same synchronous machine I will take. Okay. So let us see here how you define short pitch in this example synchronous machine. See, what is the short pitch coil? Short pitch coil means these two coil side, coil span is less than 180 degree. So instead of placing the coil side 2 in 10th position, I place it either in 9, 8, 7, anywhere. Okay. Let I place it, instead of placing in 10th position, I place it in 9th position, and this angle is let alpha, means alpha angle less. Alpha angle less, I place this conductor. Okay. So now here coil span is less than 180 degree. How much angle it less? Minus alpha. Okay. Then the coil is said to be, the winding is said to be short pitch winding. It is the winding one. By mistake I write coil. It is winding. Here you write winding. So what is the definition of short pitch winding? If coil span is less than, if coil span or distance between two conductor, distance between coil side 1 and coil side 2 is less than 180 degree electrical or 360 degree by 360 degree by pi P mechanical, P is the number of pole present in the synchronous machine, then the winding is called as short pitch winding. Here alpha is called as short pitch angle or coding angle. And in short pitch coil, this short pitch winding, your coil span is equal to 180 degree minus alpha. In full pitch coil, you have seen that the total resultant EMF induced in the coil is the algebraic sum of EMF induced in coil side 1 and coil side 2. But here you see that as coil span is 180 degree minus alpha, so instead of taking algebraic sum of EMF of these two coil side 1 and 2, here you take vector sum of the total EMF induced in a short pitch coil or short pitch winding is equal to the vector sum of EMF induced in coil side 1 and coil side 2. This one I will briefly explain when we study short pitch factor. Okay. Next we discuss what are the advantages of short pitch winding. In full pitch winding, you see that the resultant EMF is the algebraic sum of EMF of two coil side, that is coil side 1 and coil side 2. But in short pitch coil, the resultant EMF is the vector sum. Here we say it is vector sum of coil side 1, EMF of coil side 1 and coil side 2. So due to what conclusion you get that the vector sum is less than algebraic sum. It means EMF induced in short pitch coil is less than EMF induced in full pitch coil. So what is the advantages of making the winding short pitching? The first advantages is that copper is saved in the coil ends. This is the coil ends, these two portions, this is the coil ends due to less coil span. Here you see I reduce the length of the coil by shifting this 10th position to 9th position. So obviously this length of the coil also reduce. So due to which copper is saved. Second thing is waveform of induced EMF is improved. It means due to short pitching, what happen? The short pitching winding, it eliminates the frequencies due to harmonics. It reduce or totally it eliminate, like third harmonic, fifth harmonic, seventh harmonic, it totally eliminate or somewhat it reduce this harmonic frequency, due to which frequency EMF induced in the coil also improved. It is more sinusoidal. In short pitch coil, the EMF is more sinusoidal than the EMF of full pitch coil. Third point, inductance of the winding is reduced. As the length of the coil is reduced due to short pitching, hence inductance of the coil is also reduced, and also mutual inductance of the coil also reduced. Fourth point, due to short pitching, mechanical strength of the winding is increased. These are the advantages of short pitch winding over full pitch winding. Next we see concentrated winding and distributed winding. So what is concentrated winding? The same example I have taken here, a synchronous machine with 2 number of pole in the field and 8 number of slot in the armature conductor. Here I numbered the armature slot 1 to 18. And through this example, now we see what is a concentrated winding. Actually, concentrated winding, all the coils belongs to a particular phase is placed or concentrated in a single slot under each pole. Okay. Here as you see 18 number of slots are carried out by armature conductor. So how many slots comes under each pole? Here I take 2 pole, north pole and south pole. So how many number of slots comes under each pole? Here number of slot per pole is 18 number of slot, 2 number of pole. Slot by pole is equal to 9. So here you are very clear that for each pole or under each pole 9 number of slots comes. Then how many slots comes under each phase under each pole? So now I find number of slot per pole per phase. You already get number of slot per pole is 9. So per phase is 3. So now we are very clear that number of slot per pole under each phase is 3. Now I draw slots for this pole. Here we get that 9 slots are there. So I under each pole, so I draw 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly for 9th S pole, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Under each pole I have drawn 9 number of slots. What is concentrated winding? According to the definition, here all the coils under each pole and belongs to each phase is concentrated in a single slot. So how many slot, if I see North Pole and South Pole, how many slots comes under each phase? Here through mathematical calculation we get 3 number of slots comes under each pole under each phase. So 3 number, these 3 number, 1, 2, 3, it comes under one phase, 1, 2, 3, then 4, 5, 6, it comes under second phase in a 3-phase synchronous machine. Okay, 7, 8, 9, this comes under phase number 3. Similarly for South Pole also. So in concentrated winding, all the coils, they comes under or they are concentrated or placed in a single slot. Suppose the coil it's having 3 number of turns. So they are concentrated in a single slot. Belongs to each phase. Concentrated. Clear? It is concentrated or placed. So I place this coil for this phase 1 in a single slot. Similarly for second phase and third phase also. Very clear? Now you are clear what is concentrated winding? Again I say, in concentrated winding, all the coils that may having several number of turns or single turns are placed in a single slot, belongs to any one phase under each pole. Clear? Then what is the second point? Second point is that total number of EMF induced in the coil, this coil, total number of EMF induced in this coil is the algebraic sum of EMF induced in coil side 1 and coil side 2. Here we make algebraic sum of EMF to get the resultant EMF of a particular coil. Next, what the fourth one? Distributed winding. Here by name it is very clear that the coils are distributed, belongs to each phase under each pole. Here in concentrated, all the coils are concentrated or bunched in a single slot, but here instead of concentrated or bunched, it is distributed to separate slot under each pole under each phase. So how I draw the coil or how I place the coil for distributed winding? Here I take the example of 3-turn coil. 3-turn coil. So instead of bunch it in a single slot, now I distributed it in a individual slot under each pole belongs to each phase or belongs to each phase under each pole. Okay, in different way you may say. So 3 turns are there, I place it one turn, I place it into 3 slots individually. This is one coil, another coil is placed to second slot under first phase, the third coil is placed to third slot belongs to first phase, of n pole. Clear? Now you are clear what is the difference between concentrated and distributed winding. In concentrated winding, we make a bunch of this coil and place it into single slot belongs to first phase under north pole. But in case of distributed, in place of bunch it, we distributed into individual slot which comes under first phase under north pole. Clear? Second difference is that in concentrated, the resultant EMF in a coil is the algebraic sum of EMF of coil side 1 and coil side 2. But here in distributed winding, you see that there is a phase difference between slots. Under each pole belongs to particular phase. So that here instead of taking the algebraic sum of EMF to get resultant EMF, we take the vectorical sum or phasor sum. Clear? This is the main difference between concentrated winding and distributed winding. Another difference is that as here you find EMF, the resultant EMF, by taking the arithmetic sum in concentrated, its EMF is more than the EMF of a distributed winding because algebraic sum is greater than the vectorical sum. That is the difference in between concentrated winding and distributed winding. Another thing is that the EMF which one you get from concentrated winding that having harmonics, but distributed winding harmonic part is somewhat, it is totally eliminated. So in this portion you have learned the type of armature winding, that is full pitch winding, short pitch winding, concentrated winding and distributed winding. And you are very clear their comparison, means what is the advantages of short pitching the winding, and due to the reduction of harmonic, what is the effect on the armature winding. Now after completion of this topic, you are able to find winding factors such as pitch factor and distribution factor, which one we discuss in our next video lecture class. Thank you.